Let's start the lecture. In this lecture, we are going to discuss about the electric potential due to a system of charges. In the previous lectures, we already discussed about the electric potential, then electric potential due to a point charge, after then electric potential due to an electric dipole also. So, no. First, write down those formulas actually. From electric potential, we have formula V equal to W upon Q naught. And from electric potential due to a point charge, we have formula V equal to 1 upon 4 pi epsilon naught Q upon R. Yes or no? And then from electric potential due to an electric dipole, we have three formulas actually. One for electric axial line, then for equatorial, after then for any point. We know for equatorial point electric potential is 0, and for axial we have formula 1 upon 4 pi epsilon naught P upon R square. Yes or no? And for at any point we have to write V equal to 1 by 4 pi epsilon naught P cos theta upon R square. Yes or no? Just remember this formula actually. We have to use this formula here. Okay. Yes. Here what we take? Here, here is a point P. We have to find the potential at point P due to a system of charges. System of charges means here we have more than two charges. Yes or no? So what we have to take? Let here is a charge Q1 which is at a distance R1. Here is our charge Q2 which is at a distance R2 from point P, and another charge Q3 is here which is at a distance R3. Similarly, so on. Here another Qn is there, and the distance of Qn from point P is our Rn. So what we have to write? The electric potential at a point P due to charge Q1, let the potential is our V1, which is equal to 1 upon 4 pi epsilon naught Q1 upon R1. So the distance from Q1 to P is our R1. Then similarly, potential at point P due to charge Q2, point charge formula 1 upon 4 pi epsilon Q upon R. So here we have to write 1 upon 4 pi epsilon naught. In place of Q, we have to write Q2. Then distance is our R2. Similarly, for V3, we can write 1 upon 4 pi epsilon naught Q3 upon R3. And for Vn, we have to write 1 upon 4 pi epsilon naught Qn. Then, as we know, the electric potential is a scalar quantity. So, the net potential at point P must be equal to the sum of all the potentials. So, V equal to V1 plus V2 plus V3 up to Vn. Actually, here n charges are there. Q1, Q2, Q3 up to Qn, which is at a distance R1, R2, R3 up to Rn from point P respectively. So, we have n number of charges here. So, the net potential becomes V1 plus V2 plus V3 up to Vn. So, what we got here? Let's see here. V is our, let's see. Here we have to take common 1 upon 4 pi epsilon naught. So, so 1 upon 4 pi epsilon naught common नहीं जिबा. केते जो कहलु V1 पे कौन रही जिबो Q1 by R1, V2 पे कौन रही कि Q2 by R2, sorry, these are R1. Then V3 पे रही Q3 by R3 plus. Similarly, Vn पे केते रही Qn upon R. ऐसा ना. So in general, कौन लिख परिवा कहलु summation यूज करिबा. V equal to 1 upon 4 pi epsilon naught sum over I equal to 1 to up to n Qi upon Ri. Yes or no? The net potential at a point P due to system of n number, actually due to n number of point charges placed near to them. So, the formula is V equal to 1 upon 4 pi epsilon naught sum over I equal to 1 to up to n Qi upon R1. Sum over C1 plus रहेगा. तो first I रे पड़ेगा 1 Q1 by R1 plus Q2 by R2 plus Q3 by R3 plus Q4 by R4 plus Q5 by R5. Similarly up to Qn by R3. N means here we have to take 4 charges, 5 charges. If we take 5 charges, then n equal to 5. Yes or no? So this is our electric potential due to a system of charges. Yes or no?